Welcome back to my channel. In today's video, I'll be discussing about the graph of the function y equals to x square. In the last video, I've discussed about the graph of the identity function in detail, which is y equals to x. Now, for the graph of the function y equals to x square, we need to have the knowledge of parabola, as it is the equation of the parabola, as the graph of the function y equals to x was the equation of a straight line. Now for the parabola, we can see that this parabola, which is x square equals to ay, 4ay, this parabola. So we need to learn about the properties of this parabola, and from there we can draw the graph of the function y equals to x square. So what are the properties of this parabola? X square equals to 4ay. It will be an upward side parabola for a greater than 0, and it will be a downward like parabola for a less than 0. So here we have a greater than 0, for which we have the upward parabola, and for a less than 0 we have the downward parabola. And also this parabola x square equals to 4ay, from here we can see that it passes through the point 0 0. So this point here is the 0 0 point, and this point here is the 0 0 point. So this parabola always passes through 0 0 point. Now the length of the latus rectum. So before coming to the latus rectum, there is a concept of focus in case of parabola, and for this parabola, which is x square equals to 4ay, the focus is at y-axis, which is 0 comma a. So for the a greater than 0 part, we have the focus on the upward side, and for a less than 0 we have the focus in the downward side here. Okay, and there is a thing called latus rectum. So what is latus rectum? Latus rectum is the perpendicular straight line that passes through the focus, which is perpendicular to the axis of the parabola. So this one here, this one is the axis of the parabola. Here this one is the axis of the parabola. So, and this one is the focus, and here this one is the focus. So this straight line, this straight line, it's perpendicular to the axis of the parabola, and it passes through the focus of the parabola. So this is the latus rectum. So for when a greater than 0, the latus rectum, the length of the latus rectum is 4a, and when a is less than 0, the length of the latus rectum is minus 4a. Why is it minus? Because minus 4a will make, in this case, the positive length. So we have this, the length of the latus rectum 4 mod a, and focus as 0 comma a. Now we move towards our function of concern, which is y equals to x square. So we can write y equals to x square like this. So we can write 4ay. So in this case, if we compare it with 4ay, we will have a equals to 1 by 4. 4ay is the general structure of a parabola. So of a kind of parabola, there are many kinds of parabola, but we are only considering here x square equals to 4ay because we are considering the function y equals to x square. So here we have 1 by 4, a equals to 1 by 4. So from here we can see that a is positive. So positive means the parabola should be upward, and also it passes through 0 0 point, and the parabola has the focus at 0 1. So 0 1 will be focus somewhere here, and the length of the latus rectum, which is 4a, will be 1. So the latus rectum will be a straight line which passes through this this focus of the parabola. So here we have this structure. This is the structure of the parabola. This this one here is the structure of this parabola or y equals to x square function. Now, if we consider the algebraic properties or different kind of properties of this function, we can see that it is again a polynomial and an algebraic function as the y equals to x. Also, its domain is R. Why the domain is R? Because we have the function fx equals to x square. So we can put input, we can provide any input to this function, any real number is possible. So here we have the domain as R. Next is the range. Now this part becomes different because from the graph here, we can see that the parabola or the function is restricted to the upper part of the y-axis. So it must be, and it can be 0 because here we have a point 0. And also we can say that any square of a function is always greater or equals to 0. This is always greater or equals to 0. So from here we can see that the range of the function is always close 0 to open infinity. Close 0, why? Because at x equals to 0, the functional value becomes 0. Next, this function is increasing in 0 to infinity and decreasing in minus infinity to 0. For understanding the increasing or decreasing function, we must do the derivative. So if we do the derivative of this function, here we have fx equals to x square, y equals to fx equals to x square. From here, if we do the derivative will be dy dx equals to ddx of x square, which is 2x. Now, this will be positive if x is positive, and if x is greater or equals to 0, again the derivative will be greater or equals to 0. So we can say, and similarly for negative, if x is negative, then the derivative will be negative. So from here we can see that dy dx is greater or equals to 0 if x is greater or equals to 0. That is x belongs to close 0 to infinity. And similarly, this is lesser or equals to 0 if x is lesser or equals to 0. That is, x belongs to lesser or equals to 0 means minus infinity to 0. So the derivative is greater or equals to 0. This means the function is the increasing function, and this is lesser or equals to 0 means function is the decreasing function. So these two results are, so this one here is coming from this derivative property. Next is the function is an even function. So for even function, we must have fx equals to f of minus x. So here the function is fx equals to x square, and also if we put f of minus x, it will be minus x whole square. This is x square, which is again fx. So the function is an even function, and for even function, the even functions are symmetrical about y-axis. So from here we can see that this function is symmetrical with respect to this y-axis. And also for the increasing decreasing part, we can see that when the function is in the positive direction of x-axis, which is this direction here, we have this increasing property, and when it is in the negative side, it has a decreasing property. As x increases, the function decreases here, and as x increases, the function increases here. Okay. Next is continuous on R. So we will prove it by using the derivative, the definition of continuity. But before that, we can see that we can draw this function continuously like this. So this function is obviously continuous, and for differentiability also, for not being differentiable, the function must have a sharp edge. But here we can see that this function can be drawn smoothly. There is no sharp edge. So this function is again a differentiable function. So let me come to the properties to prove. So for continuity, what we must do? Suppose we have a belongs to R. A is an arbitrary real number. So limit x tends to a, fx. What is fx? What is fx here? Fx is x square. So limit x tends to a, x square. So here we have a square. And also for f a, we have a square. So obviously these two are equal. So as these two are equal, we can say that the function is continuous at a, and as a is an arbitrary real number, the function is continuous throughout the R. Similarly, for the differentiability, we must have this limit. So here, suppose we have fx equals to x square. Now we must find out the limit x tends to a. Again, a is an arbitrary real number. So we have fx minus fa divided by x minus a. So from here we can see that limit x tends to a, x square minus a square divided by x minus a. So we can cancel out the x minus a from above and below, from the numerator and the denominator, like this. As x tends to a, so x not equals to a, so we can cancel out here, and here we have limit x tends to a, x plus a equals to 2a. So the limit exists, so the function is differentiable at a, and for arbitrary number, the differentiable arbitrary number a, the differentiation gives the value a. So for any number, or the derivative of this function is obviously 2x. Now it has a minima at x equals to 0, with minimum value being 0. So here we can see from the graph of this function that it has a minima at here, it is a valley, and also it has the value of this function at that minimum point is 0. So for finding out a point of minima or a maxima, we must do the derivative and equate it to 0. So if we do that, we have the derivative dy dx. So fx equals to x square, or y equals to, so dy dx will be 2x. So if we equate it to 0, we will get critical points which will give x equals to 0. Now for proving, we must do the double derivative. So here the double derivative d2y dx2 equals to 2 from here. So it is always positive, and in case of positive, the critical point is always a minima. So from here we can see that the function y equals to x square has a minimum at x equals to 0, and also the minimum value will be y at x equals to 0 is 0 square, so 0. So it has the minimum value 0. In the next video, we will be discussing about y equals to x cube function. Thank you for watching this video, and also subscribe to my YouTube channel and share this video with others who are preparing for different exams. Thank you.